associate graphs with an XY axis drawing with maybe a curve on it, or maybe a surface in XYZ space. Let me clarify something right off the bat. The graphs that we will be discussing over the next several videos have nothing to do with what you might be thinking about in that context. Graphs in graph theory are just collections of dots with lines that might connect them. They are heavily useful in computer science and engineering. Consider the web of Facebook friends. You can imagine a universe of dots which represent people and lines that connect friends. It doesn't really matter where you put the dots when you think of this map, so long as the lines connect the right dots, exactly when those two people are friends. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below, and make sure to click on that subscribe button. Graph theory is a relatively new area of mathematics, first studied by the super famous mathematician Euler in 1735. Since then, it has blossomed into a powerful tool used in nearly every branch of science and is currently an active area of mathematics research. This problem that I'm going to show you, known as the 7 bridges of Königsberg, is the problem that originally inspired graph theory. Let's take a look. In the time of Euler, in the town of Königsberg in Prussia, there was a river containing 2 islands. The islands were connected to the banks of the river by 7 bridges, as seen below. The bridges were very beautiful, and on their days off, townspeople would spend time walking over the bridges. As time passed, a question arose. Was it possible to plan a walk so that you cross each bridge once and only once? Euler was able to answer this question. Are you? Stop and pause this video. I want you to try to find a way. You can start wherever you want, but I want you to try to find a way of starting from one island, let's say here, and going through a walk, crossing each bridge exactly once. How do you do that? Well, that was a failed attempt, but I want to see if you can find a solution to this. Well, consider a different problem. Here's a drawing of 4 dots connected by some lines. So I'm going to do a drawing here. Is it possible to trace over each line once and only once without lifting up your pencil, starting and ending on a dot, any dot that you choose? There is an obvious connection between these two problems. Any path in the dot and line drawing corresponds exactly to a path over the bridges of Königsberg. Pictures like the dot and line drawing are called graphs. Graphs are made up of a collection of dots called vertices and lines connecting those dots called edges. When 2 vertices are connected by an edge, we say they are adjacent. The nice thing about looking at graphs instead of pictures of rivers, islands, and bridges is that we now have a mathematical object to study. We have distilled the important parts of the bridge picture for the purposes of the problem. It does not matter how big the islands are, what the bridges are made out of, if the river contains alligators, and so on. All that matters is which land masses are connected to which other land masses and how many times. We will return to this question of finding paths through graphs later. For now, let's just start with an example. So Al, Bob, Cam, and Dan and Euler are all members of the social networking website Facebook. The site allows members to be friends with each other. It turns out that Al and Cam are friends, as are Bob and Dan. Euler is friends with everyone. Represent this situation with a graph. Now each person will be represented by a vertex, and each friendship will be represented by an edge. That is, 2 vertices will be adjacent, there will be an edge between them, if and only if the people represented by those vertices are friends. So let's take a look at what this would look like. Let's say here's Al, Here's Bob. Here's Cam. Here's Dan. Can you see that? Yeah, you can. Dan. And here's Euler. And I'm going to use a different color for edges just so that you can see it a little bit more clearly. So we know that Al and Cam are friends. So I'm going to draw an edge between the two. As are Bob and Dan. Euler is friends with everyone. So I'm going to draw an edge from Euler to everyone else. So that is the graph that can represent this scenario, this context. Now, there are many solutions to this. There are many different ways of drawing this graph, all of which are the same, but we'll talk about that and what that means in the next lecture. Anyways, thanks everyone, and I'll see you in the next video.